Hi guys, welcome to Concept of Mathematics. I have started a new series of lectures for class 11th which are entirely based on NCERT textbook and NCERT exemplar. I will explain each and every concept in details. We will apply this concept in problem solving as well. The first chapter in the series is sets. So without further delay, let us start the overview of the first chapter. This chapter deals with the concept of sets, operations on sets. Concepts of sets will be useful in studying the relation and function. Relation we will cover in the next lecture. So what is a set? A set is a well-defined collection of objects. Well-defined means when we ask to write the set to two persons, the answer will be same. That means they will not differ from person to person. Suppose I will ask two persons to write natural numbers from 1 to 5, they will definitely write 1, 2, 3, 4 and 5. Okay, so this is a set. Okay, there are two methods of representing a set: roster or tabular form, and second one is set builder form. If you write element wise, then it is roster form, and if we write the properties of element, then it is set builder form. Take set A. I have written all the elements of set A, so this is roster form, and I can write it in another form: set of all x such that x belongs to natural number and x is greater than or equal to x and less than or equal to 5. So both are the same. Okay. Next is empty set. A set which does not contain any element is called empty set or void set or null set, and it is denoted by these curly braces, open curly brace and closed curly brace, or 5. Okay, examples of empty set can be suppose set B equals the set of all x such that x square is less than 0 and x belongs to set of natural numbers. So this situation cannot be possible that a square of natural number will be less than 0. So in turn this will be a null set. Okay. Finite and infinite sets. A set which consists of a finite number of elements is called finite set. Otherwise the set is called infinite set. Okay. Finite means we can count its elements, or that the set which elements are countable. Okay. Empty set is also a finite set. Okay, because the elements in the empty set is 0. That is, number of element in B is equal to 0, and here number of element in A is equal to 5. The cardinality of set is 5. Now what is subset? A set A is said to be a subset of set B if every element of A is also an element of B. What does it mean? Suppose I have written a set here A, B and C, and another set A which elements are A and B. Then every element of A and B is also an element of B. Okay, so we can say that A is subset of set B. Okay, in symbol we can write like this, and this implies A is element of A implies A element of B also. We denote set of real numbers by capital R, set of natural numbers by N, set of integers by Z, set of rational numbers by Q, and set of irrational numbers by T. Okay, we observe that the set of natural numbers is subset of integers, and it is subset of rational number, and it is subset of real number. Okay, next is irrational number. Set of irrational numbers are subset of rational number. It is true, but set of rational number is not subset of irrational number. Also, set of natural numbers is not subset of irrational number. Next, what is equal sets? Given two sets A and B, if every element of set A is also an element of set B, and if every element of B is also an element of A, then sets A and set B are said to be equal. The two equal sets will have exactly same elements. Okay, so suppose a set A which elements are 1, 2 and 3, and another set B which is defined as the set of all x such that x belongs to natural number and x is root of this polynomial equal to 0. Okay, so in turn we can write B as 1, 2 and 3. So all the elements in set A are there in set B, and all elements in set B also lies in set A. So we can say that A is subset of B and B is subset of A. This implies A equals B. Now intervals as subsets of R. Let A and B belongs to set of real numbers and A is less than B. You can represent it on number line by this way. An open interval denoted by open parenthesis A comma B close parenthesis is the set of real numbers, that is set of all x such that x is greater than a and less than b. This is the visual diagram. A closed interval denoted by square bracket a comma b is the set of real numbers such that x is greater than or equal to a and less than or equal to b. Closed interval, this one. All numbers from a to b. Here it was numbers was between a and b, not a and b. This is a interval closed at one end and open at other are given by, this is a close at a and open at b. This means that the set of all x is that x is greater than or equal to a and less than b. That means x will not be equal to b. Okay, and this will represent the set of all x greater than a and less than or equal to b. Okay, so what is power set? The collection of all subsets of set A is called power set of A. It is denoted by P of A. If the number of elements in A is equal to n, that is n of A equals n, then the number of elements in power set of A is equal to 2 to the n. Using the notations, we would write P of A is equal to set of all set of B such that B is subset of A. So, how would you prove that the number of elements in power set is equal to 2 to the power n? Let us see. If we have number of elements is equal to n, then in power set we can choose none of this, and we can choose 1 also, we can choose 2 out of n also, and like that we can choose all of the element at the same time, and this is equal to an expression 1 plus 1 raised to the power n, which is taken from binomial equation, and it is equal to 2 to the power n. Okay, so let us take an example. Power set of set A or 2 to the s represents the set containing all possible subset of S as its elements. For example, this is notation only. P of S or 2 to the s are same thing. Let us take a set S which elements are 1, 2 and 3. We can write power set of S as phi is element of every set, so phi subset, and 1, 2, 3, take 2 at a time, 1, 2, 1, 3, 2, 3, and take all at the time. So this is power set of S. Okay, we can note here number of element in S equals 3. So what is the number of element in P of S? It is 1, 2, 3, 4, 5, 6, 7, 8. So it matches with our conclusion above, which is 2 cube. Okay. Now let us see some properties of power set. Power set of a finite set is finite. Of course, it is true. If a set is infinite, then power set will be number of elements in power set would be 2 to the sum infinite. This will lead to infinite. Okay. Set S is an element of power set of S, which can be written as S belongs to power set of S, which is true, as in the given example S is written here, and it is also a subset of power set of S. Okay, so we can write it as 1, 2, 3 belongs to, that is, it is element of power set of S. Okay. Okay. Empty set phi is an element of power set of S, which can be written as phi is element of power set of S, which is true. It is there. Okay. Empty set is subset of power set of S, which can be written as phi is subset of power set of S. Okay. If we write a subset of this power set, then the first would be phi. Okay. Then phi enclosed by another curly braces, and so on. Okay. So this is element and this is set. Okay. So this is subset of power set of S. Next is universal set. This is a basic set in a particular context whose elements and subsets are relevant to that particular context. For example, the set of vowels in English alphabet. The universal set can be set of all alphabets in English. Universal set is denoted by capital U. It is always important to decide what is universal set when we are dealing with sets. Suppose you are talking about your class, then the whole strength of your school will be taken as universal set. Okay. Also, when you are talking about some numbers, that is 1, 2, 3, 4 and like that, then the set of natural numbers can be taken as your universal set. Okay. So universal set might be differ depending upon a particular context. Okay. Let us see Venn diagram. Venn diagram is a visual way to represent a relationship between sets. For example, the set of natural numbers is a subset of whole numbers. Okay. This is, suppose this rectangle represents set of integers. Okay. In this context, our universal set is Z. Okay. Then the n, capital N, represents natural number, which is subset of whole numbers. This outer circle. Okay, this outer circle includes this inner circle also, and this whole number is subset of the integers. Okay, so Venn diagram is a visual way to represent a relationship between sets. Okay, next comes union of sets. The union of any two given sets A and B is the set C, which consists of all those elements which are either in A or in B or both. Okay, suppose this is our universal set, and this is set A, and this is set B. Then A union B is represented by this whole thing. So the elements in A union B will be either in A, purely in A, or their intersection, or in B. Okay, the intersection of A and B represented by this person, which is common element of set A and B. In symbol we write C equals, that is set C equals the union of set A and B. Okay, in set builder form we can write it as the set of all x such that x belongs to A or x belongs to B. By using Venn diagram we can represent the union of set A and B as given in this figure. Okay, so the elements in set A union B will be either in A or B or both. Okay, if set A and B are disjoint sets, okay, that means there are no common elements between A and B, then this will be represented as this diagram. The separation between A and B shows these are disjoint sets. Okay, some properties of the operation of union. The union of A and B equals the union of B and A, which is very straightforward. The union of set A and null set is equal to A, which is also straightforward. Okay, the union of universal set and a given set A is equal to U. Okay, this can be understood as, suppose this is universal set and this is set A, then union of A and U will be the whole thing. Okay, next is union of A and B, and then union of C is equal to A union the union of B and C, which is also not difficult. Union of set A to itself is equal to A. Next comes intersection of sets. The intersection of two sets A and B is the set which consists of all those elements which belong to both A and B. Symbolically, we write the intersection of A and B is equal to the set of all x such that x belongs to A and x belongs to B. Okay. By using Venn diagram, we can show it. This portion, this shaded portion, represent the intersection of A and B. That means elements falling in this region will belongs to A and B both. Okay, if A and B are disjoint sets, that is the intersection of A and B equals null set, then also this is that means no elements are common in A and B. Okay. A intersection B equals B intersection A, which is goes true. The intersection of null element and a set A equals null element, null set. Okay. Union of the intersection of universal set, U represents your universal set, and set A equals set A. Okay, the intersection of set A to itself equals A. Now coming to operations of three sets, the intersection of A and B, that is intersection of A and B will be represented by this portion. Okay, to intersection of C, that is C, only this region will let us highlight this, only this region, okay, will represent the intersection of this thing. Next, A intersection of B intersection C. So B intersection C will be represented by this one, and with intersection of A, this will only be this person. Okay, so both are same thing. Similarly, we can prove these also. Now let us come to some important properties related to union and intersection. That is, when we are dealing with words problem, then this will come to very useful to us. Okay, union, suppose U is universal set here, or M, set M represents the teachers who teaches maths, and set P represents the teachers who teaches physics. Okay, so M union P, that is union of M and P, represents at least one out of two subjects. Okay, that means one or two. Okay, or both. The intersection of math and physics, this will represent the number of teachers who teaches both subjects. Okay, the number of teachers who teaches only mathematics will be represented by intersection of M and complement of P. We will read complement of a set in the next overview of chapter, when we will go through relation and functions. Okay, now only physics will be represented by this diagram, that is M complement intersection of P. Let us see what is complement. The complement of set, suppose this is a set, then complement of a set can be visually represented by other than A, okay, or you can say not A, okay. So only physics teachers can be represented as not math intersection physics, okay. You can pen down it in another form, P minus M. Exactly one of two subjects can be represented by this Venn diagram. This will be M intersection P complement union M complement intersection P, or in other way we can write it as M minus P union P minus M, okay. These are the same thing. Next, when we are dealing with three sets, then the union of A, B and C represents at least one out of three subjects, okay. That means at least one means math or physics, or math, physics and chemistry, okay. So all three subjects will be represented by this one, and this will be intersection of A, B and C. Only one subject out of three subjects can be represented by Venn diagram as follows. This shaded region will be A minus intersection of this one, that is A intersection C, and subtracted by intersection of A and B, plus additionally we have subtracted this region 2 times, so we will add once to equate only A, okay. Exactly one of A, B and C will be represented by A intersection B complement intersection C complement whole union with A complement. We are dealing with this region, A complement intersection B intersection C complement, okay, and again union with set A complement intersection B complement intersection C. Now coming to exactly two of them, that means exactly two of them happens at the same time, then this can be represented by union of A intersection B intersection C complement to A complement intersection B intersection C, and again take union with A intersection C intersection B complement, okay. Now coming to at least two of them occurs, then this will be represented by Venn diagrams by given set. At least two means two or all, okay. Next comes difference of sets. The difference of sets A and B denoted by A minus B is defined as set of elements which belongs to A but not to B. As I said earlier, it is A not B. Okay, this one we write A minus B set is equal to the set of all x such that x belongs to A and x does not belong to B. This is represented by this Venn diagram. Now coming to B minus A, this is also a set which is equal to the set of all x such that elements belongs to B but not in A. Okay, complement of a set. Let U be the universal set. We can skip this one because I have already covered the complement of set. Okay, but we will cover these notations. The complement of set A equals the set of all x such that x belongs to U, that is universal set, and x does not belong to A. Also, the complement of set A equals U minus A. Okay, some properties of complement of sets. Law of complements. The union of a set with its complement is equal to universal set. Okay, this is set A and its complement are shaded in red ink. The union of this one to the whole thing, remaining thing, is equal to universal set. The intersection of A to its complement equals null set. Now coming to De Morgan's law, the complement of union of A and B equals in the intersection of complement of A and complement of B. Okay, how will we represent this? Let us take it by visual way, that is Venn diagram. This is represented by A union B. This is A union B. Suppose A and B, the complement of this one will be this region. Okay, the remaining thing represents the complement of A union B. Okay, then on right hand side, the A complement will be the whole thing. Okay, suppose A, and B complement will be represented by this one. Okay, so what will be the intersection? Intersection will be this portion, okay, which is lying outside of union of A and B. Okay, the complement of a set equals the set itself. The complement of universal set equals null set, and the complement of null set equals universal set. Okay, now coming to some formulas to solve practical problems on union and intersection of two sets. Let A, B and C be any finite sets, then number of elements in the union of A and B is represented by n A union B, which is equal to number of element in A plus number of element in B minus number of element in the intersection of A and B. We will now prove it. So let us use as universal set, and this is set A, this is set B, and number of elements in set A equals A plus C, and number of elements in set B equals B plus C. Okay, C elements are common to both A and B. So number of elements in the union of A and B is equal to A plus B plus C. Okay, by using associative properties, we can write it as A plus C plus B plus C minus C. We have added the number of elements here C additionally, so we have subtracted C. By writing this way, we can write A plus C as number of elements of A, B plus C will represent number of elements in set B, and C will represent the elements, number of elements which are common to both A and B. So this is the easiest way to prove this equation or formula. So let us consider some constants. If the intersection of A and B equals null set, then number of elements in union of A and B equals number of elements in A plus number of elements in set B. Suppose set A and B I am giving here. This means the sets are disjoint, then union will be represented by this one. So N A union B will be equal to number of element in A plus number of element in B. Okay. Now coming to operations of three sets. This long formula, okay, the union of number of elements in union of A, B and C will be this much. Okay, let us consider one by one. I have written number of elements in each region by different letters. Suppose this region, only this region, the number of elements are A. Similarly, number of elements in this region is B. This one E, D, C, E, F, like this. Okay, I have counted all the elements in the regions given here. So the number of elements in set A can be written as A plus D plus E plus G. Similarly, number of elements of B can be written by this way: B, E, F and G, sum of all these numbers. A, B, C, D, E, F all represents a natural number. Okay, number of elements in C equals C plus D plus F plus G. C plus D plus F plus G. Okay, so by adding these equations, we get N of A plus B plus C is equal to A plus B plus C, A plus B plus C plus 2D plus 2E plus 2F plus 3g. Okay, now we will separate the numbers once, that is a plus b plus c. Our motto is to find the union of these three sets. Okay, so we will write it as written here. Okay, a to g plus this remaining one d e f can be written here, and we have taken 1g inside this parenthesis, so we are left with 2g. Now this whole thing represents the number of elements in union of a, b and c. Okay, plus remaining d, e, f and 2g are there, so we can write e plus g, e plus g. Okay, this represents number of elements present in intersection of a and b, this one, and f plus g will represent the number of elements present in intersection of b and c, and the d plus g, we are deficient with g here, so we will add and subtract as we have done earlier also. So this will represent d plus g, the number of elements present in intersection of a and c, and g will represent the intersection of all sets. Okay, so by manipulating some elements left and right, we can write it as number of elements in the union of all sets equals n of a plus n of b plus n of c minus intersection of this one, plus this quantity. Okay, so this is a easy proof. Okay, by this we finish the overview of the first chapter. In the next video we will apply this concept while solving the problems. So thanks for watching, and if you like this, please subscribe, share and like.